In this video, we're going to look at a little quick review of some polynomial vocabulary that you should have learned in the past. Starting out at the top here, we've got a review. It says write S if the expression is in standard form, write N if it is not. We have to remember what this word standard form, what that means, and that means we're going to start from the biggest exponent and we're going to work our way down to the smallest. And we also have to combine like terms. If we have any. So is this one in standard form? No, it's not, because these are out of order. The second one, yes, it's in standard form because the exponents are lined up with the biggest down to the smallest. The third one is also in standard form, even though it doesn't have a constant term on the end, it's still from the biggest exponent down to the smallest. So we have this word, vocabulary word, polynomial. That's how we say that. Polynomial related words are monomial, binomial, and trinomial. They all have that same suffix in the end. And then each of the prefixes is different. So a polynomial is a monomial or the sum of monomials. So again, what's a monomial? A monomial is just anything that's one term. And these are all examples of little one-term things over here. So we can take anything with one term, or we could add up multiple terms. So which of these expressions is a polynomial expression? Not this one. We're not allowed to have this t down here on the bottom. This one is a polynomial expression. Everything has a nice exponent. This one is not a polynomial expression because it's got it divided by x on the bottom. As far as what polynomials look like, lines are polynomials. U-shapes are polynomials. This thing is called a hyperbola. It's not a polynomial. Polynomials are nice functions. They're nice and smooth. They can have little bumps in them, or they could make W shapes, but they'll always be functions. They'll always pass the vertical line test, and they are nice and smooth. Down on the bottom here, we're just counting the number of terms in each polynomial. So for 4 here, we've got 1, 2, 3 separate terms. For number 5, I've got 1, 2, 3, 4, 5 separate terms. And for number 6, I have 1, 2, 3, 4 separate terms. Notice on each of these, there was no combining of like terms that I could have done. If I were going to do that, I probably would have done that before I counted. Then we have a chart that tells us how we can classify its polynomial by its degree or by the number of terms. This word degree, the degree is the biggest exponent when it's in standard form. So everything has to be already multiplied out and put in order. We can't leave it in factored form. We have to have it all multiplied. Oops, that's form. Okay, so if the degree is 0, that means we don't have any x's. An example of this is 5. That's called a constant function. Our function here has one term, which makes it a monomial. Mono is a prefix for 1. The second thing is a degree 1. A degree 1 is a linear function. An example of that is x plus 4. That example has 2 terms in it, which makes it a binomial. The prefix bi means 2. If our degree is 2, then we are a quadratic because we're an x squared. The example they gave us is just a single term, one term, a monomial. You could have had additional terms on there that had an x or just a number. If something is a third degree function, it is a cubic because the biggest exponent would be a 3. In this example of a cubic, I also have a quadratic term and a linear term. So I have 3 total terms, making it a trinomial. The prefix tri means 3. A 4th degree polynomial is a quartic. You see that word quart, like quarter in there for 4. A 4th degree polynomial has an exponent of 4 as the biggest power. The example they gave us has 2 terms. It could have more. So since it had 2 terms, it was a binomial. The last one on here is the degree 5. The degree 5 is a quintic, Q-U-I-N-T, stands for 5. This would be an x to the 5th function. In this polynomial, there's 4 different terms. We stop coming up with our prefixes right here, and we just sort of lump them together, and we call it a polynomial with however many terms I want to say, a 4-term polynomial, a 5-term polynomial, etc. I don't need to worry about all of those words. Okay, so go ahead and pause the video while you do the rest of the worksheet, classifying the polynomials, and then you can see what you got when you check it. So first we were supposed to write that polynomial in standard form. When we write the polynomial in standard form, it would be 5x to the 4th plus 3x cubed minus x. If we classify this by the degree would be a 4th degree polynomial function, which is also called a quartic, right? It's called a quartic function. It's a 4th degree polynomial. By the number of terms, it had 3 terms, which makes it a trinomial. It says use the words in the table above to name each of the monomials based on its degree. So this one, degree of 3, which makes it a cubic. The next one, a degree of 1 if I had to put an exponent there, which makes it linear. And then the next one we had was an x to the 4th, which was a quartic function. Quartic is the word for 4, quarter, like a quarter, 4 and a dollar. Number 8, the polynomial is written in standard form below. Underline each term. So we have 3 terms that are underlined. Then circle the exponent with the greatest value. The exponent with the greatest value was 4, and that's what tells us that in number 9, this is a 4th degree polynomial, or again called a quartic. By the number of terms, it has 3 terms, which makes it a trinomial. These are things that we really just need to memorize this vocabulary and be comfortable using it when I use it in class or when you see it come up in your work.